Hello, everyone. So we are going to start right now. I hope everyone is doing well. And today we are here for celebrating Arduino's birthday. And we'll be talking about a lot of topics. I hope all of you will really like it. So let's do. Um, to begin with, I would love to let all of you know that we are organizing this workshop from New Zealand and organized by two organizations. First is Robots Got Talents. It is one of the very well-known organizations, non-profit worldwide, and it is providing quality um, courses completely for free. And also they have apps and websites, and they also organize a lot of courses, a lot of seminars and workshops in past few years. And also I would love to talk about DreamsAI, which is also collaborating with various brands and organizations to work with microcontrollers and related technologies to provide something that is completely dream for now. They are working on some futuristic projects as well, and they are trying to make everything easy for everyone who are even not from background electronics or engineering backgrounds. Even for those who are not into science, they can also start to do that. So they are providing that platform for everyone. And let's talk about uh, okay, I would love to call Mr. Youssef to uh, play the welcome message. And today I'll be the host for all of you. I am Sandipan Chanda from RGT, and I am head of the events. So yeah.
Hello, everyone. Can you hear me?
Yes, you are audible,
Yeah,
Youssef.
awesome. And can you see me now as well?
Yes,
Right.
you're welcome.
Yeah, thank you. So I'm Youssef Osman, the founder and president of RGT. First of all, I want to thank you all for making time to join us today in the Arduino for Educators workshop. That's an official workshop by RGT, DreamsAI, and approved by Arduino for the Arduino Days 2025 celebration. First of all, I want to apologize for any inconvenience that have happened today. We've been running through a lot of technical issues, which affected the progress of the meeting, as you can tell, and that was the reason for the delay. But again, thanks for being able to make it to the meeting now. Sandipan, could you please close your mic? Thank you. So again, it's awesome to have you all here. I've checked the form submissions. I found that a lot of people have joined us from the UAE. So I'm originally Egyptian, but I'm living here in New Zealand. So I want to tell you all رمضان كريم وشكرا جدا لحضراتكم انكم قدرتوا تكونوا موجودين معانا النهارده في رمضان. And I hope this workshop is quite beneficial for you. So overall, I'll tell you the aim of this workshop. We mainly aim to just put you on the kind of the road. So we're just gonna give you an introduction for Arduino, so you don't have this impression that no, that's difficult. Let's continue working with the basic sets and where the blocks-based programming. No, Arduino is awesome, and in this workshop we're aiming to show you the benefits of Arduino and how it could be an amazing tool for your classroom. Uh, I used to teach robotics for a while, so believe me, Arduino is an amazing tool. Tomorrow I'll be with you in the show and tell section. to show you a few of the projects that I did with Arduino that can like inspire a little bit to do amazing projects in your career and for your students. Again, thanks everyone for joining. Thanks Sandipan, Murtaza, and Abdelaziz for their great effort in this workshop. I'll see you again in today's session in the Arduino education part. Okay, great. Thanks everyone, and I'll leave you again with Murtaza, with Sandipan. Sorry.
Thank you, Youssef. Thank you
Thank you.
for the awesome speech. I'll go through with session one, which is show and tell. And yeah, let's go to show and tell demonstration from my side. Yes, session one, yes. Okay, so sorry for the inconvenience caused. I took some time, maybe some server issues or something like that. Sorry for that. So let's talk about Arduino first. So what is Arduino? As all of you know, or might aware of, Arduino is an open source electronic board, kind of a hardware which is really easy to use because of the software and hardware combination they have and the IDE they provide. It really helps us to write simple programming codes which were not available before Arduino. So that's why Arduino is really easy to use and very popular among all of us. And I think each and every user or maker use Arduino to start their journey into this electronics or programming or maker world. And as we know, Arduino is not only easy to use, but also inexpensive. And sometimes we always use a clone version, which is much easier than original one, as we all are used to use with clones. And then we also should know that it is cross-platform, so we can use it with Mac or Windows or Linux. Even we can use it sometimes a Chromebook who doesn't have all, even sometimes possible with tablets too, who doesn't have access to use full frame or full featured computers like that. And as I already mentioned, it has IDE, which is very simple. And as we always know, Arduino is completely open source. The softwares are open source and also hardware are also open source. So let's talk about how Arduino was born. So there was some guy, their name is Massimo Bunzi and David Quartilis. They were actually trying to create some projects, and then they were thinking, I think 20 years ago, they were thinking, because there was no such available options at that time, there is no easy options. If you have to build kind of a projects at that time, it was really a hectic process because forget about makers, even the professionals had to take long time to just design some microcontrollers to start with some prototypes. So they thought, why not to use something really easy that would be easier for everyone, even for school students or kids, to build something they want. And in that way, they started to, they collaborated with this guy who was the creator of Wiring, framework for easy framework for electronics, microcontrollers especially, Hernando Barragan, this guy, and they together founded Arduino fast board on in 2005, and that's how they started. And the first was one like very inefficient. That was not that good, but they continuously involved and took help from various communities. Even though that time the internet was not that good, and they had a lot of problems, but ultimately they thought to make it open source, and that's how they progressed a lot. Now let's talk about how many boards or what kind of boards do we have in Arduino. So usually we know all about Arduino Uno, Arduino Nano, and Mega. Sometimes there are other boards like Dew. I think all of you are familiar with, but they are not that common. Usually Arduino Uno is common, very common, and R3 version especially among all of us. But we also have Arduino, especially has two kinds of boards or family of boards. So for one for makers and another for professionals. So for makers, they have MKR family, which is very new, and classics, which were they started with, and Nano family, the smaller version of classics, and Mega, the wider version where you have most powers and at the same time so many IO inputs outputs pins, so that you can use a lot of sensors with or modules at the same time. And for professionals, they have recently introduced Potenta family, Pro Solution and Kits, Nikla family, and also Opta kind of boards. They have integrated a lot of sensors, and they made a lot of solutions that were really not that easy before, but now they are easy. You can easily use, uh, or you can easily begin with email and some computer visions, and you can even do a lot of things that were not possible before without Arduino. Now let's talk about what things can we do with Arduino. As you know, Arduino can be used to build anything you have in your mind, anything from robots, from airplanes, from rockets, from even satellites. I don't know if you know or not. There are kind of satellites built with Arduino, and uh, you can build anything, almost anything. But there is some limitations because Arduino is not that powerful. But you can still use Arduino's platform to use it. And as Arduino is open source, you can use their schematics and their firmwares and everything to build your own powerful Arduino kind of using another co-processors or MCU. So that can be done too. So we usually, when we start, we control LEDs, we read sensors and get outputs of sensors. We make some automation systems like IoT or home automations, or sometimes we control robots wirelessly using clouds that are also possible. We do um, automation of automation for trees or plants. We do, even I have seen some projects where some guys were making automation for their fish because they don't have time much for maintaining aquarium. So usually they go to somewhere else, so they don't have time to uh, feed foods or those seeds to fish timely. So they use Arduino to automate it, and you can use a lot of things. So it is endless possibilities, I can think. So now let me talk about my projects, some of my projects, what I have done. So usually I started with Arduino because I thought, why not to use it? Even though at that time when I started, Arduino was not that familiar. And Arduino was also um, very hard to find, I should say. And the original boards were not available at all. Only some clone boards, but it was really hard to find and also very expensive. But after that, day to day, year to year, they have made it uh, with the help of China and all stuff. They have made it really cheap, and we found a lot of company came up from various countries, especially Seed Studio, Adafruit, SparkFun, and DF Robots. They really made a lot of progress with Arduino, compatible sensors, modules, and projects even. and that helped us a lot to get into Arduino. So I have made some projects. So let's talk about some beginner projects I have done few years back. I think you all are familiar with this, like clap sensing lighting systems or clap sensing, sensing a clap with sound sensor. It was really that easy, but we could also do it like kind of a 2.0 to find the specific waveform so that we don't get any false outputs. But that can be done. And second, I did was wireless control robot with dual motors for directional movements. It was also very easy, but it is something we should start with to gain knowledge of analog inputs and all stuff. Then I got into some sensors to check temperatures, and then automated a fan to turn on and off using relay. That is also very beginning projects. Um, and there are so many, but I would not love to extend on those. And then I have made a very easy line follow robot using Arduino and IS sensors to basically find the black line. And then there were RC model airplanes or airplanes, and there were various variations I have made. And using Arduino to kind of use as a two Arduino there was, and one for transmitter, one for receiver, and we made it with NRF. I think all of you know. It was not. It was really tricky to use NRF with Arduino because 5-volt logic. If you have worked, you know about it. So it was about, and NRF works on 3.3, so it was really tricky, but yeah, it works. Even though it doesn't have much good range, but yeah, it works. And then I have made a home automation system using Arduino, but as Arduino didn't have Wi-Fi, I had to use ESP8266, but then it didn't work, so I had to go with ESP32 and Node MCU, so that was later part. And then I thought, why not to use real-time feedbacks using um, why not to use something that is different? So I wanted to use real-time feedback. So basically, what happens when you create home automation system? We don't understand if someone turns on and off from the physical switch or button uh, from the switchboard. So if we implement this real-time feedback system, then we can easily get that feedback into our app like Blink or Arduino Cloud ID or whatever we are using in any custom app. We can get that feedback. So that is really easy. And then I made some telepresence robot with the SP32 camera and some kind of Roomba robot, uh, uh, model of Roomba robot kind of, and some companion robot, some RC boat, and some face recognition system. That's it. So now let's talk about drones as we chose that topic, and these are the photos of my drone made with the Arduino flight controller. Uh, so these are the photos. And now let's talk about drone or multi-rotor. What is drone? Drones are something that flies. It is kind of a robot too. We can say a flying robot. And these drones are fixed rotor or fixed. They don't have variable pitch. So these are not like helicopter, but not like airplanes too. So they can hover at unique, and they have a lot of better features than helicopters, traditional helicopters and airplanes. So I have thought to made a drone first using KK and APM, and then I thought PXHawk, but then I left those ideas and I thought, why not to use Arduino? Even though I used Arduino Uno first, it didn't work, and then Nano, it didn't work, and then I had to shift to STM32 using first I try to use Arduino IDE, and then I had to use some other IDEs to make it work with. So let's talk about types of drones. So drones have various types, as we see. So there are monocopters, which has one blade or rotor, dual copter, two rotors, tricopter, three rotors, quadcopters, which are really common, as we all know about DJI and all. So they use quadcopters, four rotors, hexacopters, six rotors, and octocopters, eight rotors. And also there are like 16 blades, rotors, and there are more too. I think this drone is made by Amazon, yeah, which has, or Intel, which has 16 rotors. Yeah, and also they have different kind of configuration like T, Y, plus X, this kind of shapes. Now let's talk about how to build a drone. So we need a lot of components, and building a drone is not easy because it really needs a lot of careful considerations and a lot of patience and a little bit financial stability too, because every time you try to do something, and because of a little bit, even a little comma can make a lot of disturbance, and you can crash a whole drone, and even the drone may catch fire. So it can happen a lot of things too. Um, so let's talk about the components we require to build a drone. So first is frame, and then we need motors and ESC. Let's talk about quadcopters. So we need four motors, four ESC, and propellers. We need four propellers, and flight controllers, of course, which is essential for flying a drone. Without flight controller, no one can fly a drone. A drone will never fly without flight controller. And for flight controller, we need IMU to stabilize it, and also GPS and compass, barometers, those are separate parts. Um, and then we need battery and power module, PDB, and RC receiver and transmitter, of course, for manual control. And we can also use GPS and course log with the computer, compass and computer. Also, we can use like single board computers to make it completely autonomous. Yeah, like that. That could be possible too. So let's talk about how we can wear it, how we can make assembly it. Um, so first we need the frame, and then we put motors and AC in a known configuration, and then we should use flight controller, and then signal connections. We should use we have to use in configuration with ESC and motors. And if we are using with PWM outputs, we also use PWM. I had used PPM because PWM didn't work well. It has some problems that has a lot of vibrations because drone is constantly vibrate when it flies. So PWM doesn't work well. And even for high end drones nowadays, like DJI and all, those brands don't even use PPM. They use dbus, which is just we just need only one where to configure all the channels, and then RC receiver integration. We need to put RC receiver, wireless one that we can control with our transmitter, and power distribution, of course. That should be, and all of these should be calculated first before using, otherwise the drone will not fly. And we need software and calibrations. We what we do usually, if you are using Arduino, you can use multi-V, which is not that good if you are not into PID, and then iNav or custom-based PID softwares. What I have done is custom-based PID software, writing from scratch with the help of multi-Y and all. But yeah, you can do whatever you like, and then must have to do IMU calibration first to check all the sensors, especially gyroscope and accelerometer, if they are working well, and if they are giving good inputs and outputs without interfering. So there is kind of electromagnetic fields too, because there is a motor, uh, brushless motors and AC, so that can also affect a lot of things of flight controller, so we should be really careful about that. And we should also do ESC throttle calibrations, otherwise the motors will not have same speed and the motor will first the drone will fly and then it will crash. And then PID tuning, which is most important for flying the drones safer and safely, and also to make it hover. And then fail-safe configurations, of course, because we can't confirm the drone will fly well or not, and for that we must configure fail-safe options. And then the last part is testing and flight. So it is never-ending process. We have to learn and fly, and it is kind of iterative process. We have to every so it took me around like 8 to 9 months to complete it, and I had also failed a lot of times. I made around 8 to 10 variations of the flight controller systems with Arduino and other. I was also doing a lot of testing, so we have to test every few days to get into that point where the drone really can fly like DJI. Even not DJI, but yeah, like that way it will be stabilified. So yes, and you are after it completely flies, it flies well. You have to check hover if it is hovering well at the same point, and if it is having some vibrations or not. So you have to find it before you fly it high, because if you don't do it, it has chance that when the wind gust will be higher, it will crash. And you also have to check sensor feedbacks if it is working well or not, and how it is working with wind gust and sudden drifts. And also, if you are using other sensors like barometers, compass, and GPS, you can also add some flight modes. And after that, every flight you have to understand how it was doing, and you have to fine tune PID every time to balance it better. And then you can also have to check like for the soldering where you have done is okay or not, if there is any kind of water or dust or something like that. So I have to um, check all the connections and again be ready for the next flight. And the conclusion is it is really challenging, as I have already mentioned, and it's not that easy. But if you really want to learn a lot of things at the same time, then you should go for Arduino flight controller. It is a great journey, and you can really you will all of you I suggest will really learn a lot and lot of things while doing it, because I think in the journey of this, if you can build it, you will be also able to build some robots that needs PID. You will learn PID, you will learn IME, you will learn balancing, you will learn designing, you will learn calculations, you will learn a lot of things. So you should go with if you have time. Thank you. It was my project, what I wanted to tell about. Now let's talk about what I I can do with Arduino boards, what kind of high level projects can be done also with Arduino, what we usually do or think about, like we cannot do with Arduino because of the limitations and limited speeds, but we can still do it. Like we can do Arduino based CNC machines. We can also build kind of self-driving, not fully autonomous, but yeah, a little bit, I can say 80% autonomous or 70% autonomous self-driving Arduino cars or robots with GPS and IMU. Just we used like IMU in our drone, like that. And we can do automated stage attendance system using face recognition. We can also use smart garbage bin with automatic sorting system using computer vision, LoRa-based long-range um, smart farming system. We can also do. There are a lot of people that have done it too, and we can build kind of robotic arm. We can build quadruped walking robot, gesture control robot, Arduino powered hovercraft, and biped humanoid or self-watering plant, what I have already mentioned before. And yeah, so I have concluded already, but yeah, I have the physical drone with me, so I'll be showing it to all of you. So this is the drone I was talking about, as you already saw in the photo, the drone. So these are, it is quite a quadcopter configuration and X. So as you can see, it is like X. It's not plus actually. It looks plus if you do lightweight, but it is X actually. And these should be configured in a way. And these are the, okay, you can see the drone? Okay, I think you can see the drone now. Yes. Okay, let me go to the photo. Yeah, you can see the photo here. So this is the drone, and you also have 4 ESCs as I talked about, and one LiPo battery, and the whole flight controller system here with sensors. I actually use two sensors for redundancy system. So I have two. If the drone is flying up and somehow one sensor is not outputting well, and the drone thinks it can crash, so it will change to automatically change to second sensor, which is IMU, for redundancy purpose. So the drone will not crash at all, even it has some problems with the one sensor. So I have used two sensors, and wireless, this is wireless transmitter and receiver system. This is receiver especially. And this is the STM32, and there is one Arduino Nano and indication system, and that's it, and the wiring and all stuff. And these are the motors that can be configured using like CW and CCW. So start with CCW, CW, CCW, and CW. So it can, so that it can balance well and doesn't have any yaw drift like that way. So if we don't do it, for example, if we just all the motors or rotors are moving in the same direction, the drone will be like, it will fly. It will not fly, not like that. It will fly, but it will be always like doing this and this. Like it will rotate so fast, and you won't be able to control it well. So, and then it will crash. So that's why we have to have like two in CW configuration, like clockwise, like this way, from right, and two into CW counterclockwise, like left from left. So these are the configurations, and I think all of you might know, have a good knowledge of this, and you can easily find all of this on Google or anywhere you like to find. But yeah, once you try to build it, you'll really gain a lot of knowledge that you can never learn from anywhere. So that's what I wanted to tell and wanted to inspire all of you about. And after all of our presentation, there will be sessions to Q&A sessions, and you can ask me any questions you have in your mind. I'll be, of course, happy to answer all of your questions. Thank you.
Me introduce Murtaza to you. Murtaza is the educational director at RGT. He has amazing experience in education and in robotics, coding, electronics. He has been doing this for years and he's really good at it. It's such a pleasure to have Murtaza in our team, and he'll be joining us in person tomorrow to further explain and give you more practical tips on Arduino and education. So let's
Good
now
afternoon,
go to
everyone.
this
Welcome
presentation.
to Arduino Days 2025. Today, my name is Murtaza, Education Director at Robots Got Talent, and I wanted to share with you what Arduino Days is and how Arduino is impactful in education. Now, computers are making, there's a news which came a few years ago where computers are making slow progress. But at the same time, Moore's law talks about that the number of transistors and microchips are doubling every 2 years. We can see that right now with artificial intelligence, NVIDIA chips skyrocketing, and the whole data center need really skyrocketing. But what we also see under the hood is things like Tesla trying to make an AI vehicle. uh, no, the things getting smarter with O-rings and watches. So where does this physical computing fit into the education sector? Now, most of us know Arduino with this Uno board. What's on the screen is the Uno R3, which had an 8 mega chip. But a lot of things which Arduino does is on the education sector, which is fairly unknown to a lot of educators. So, what is Arduino? Arduino started 20 years ago as an open source hobbyist project, but it slowly transitioned into a combination of DIY kits, hands on learning with something very easy to use and code. And that is what I'm going to share with you today. So, if you have an idea of designing a plant, a smart watering plant, or an automated irrigation system, all of that is possible with the Arduino board. But Arduino is not just a Uno board anymore. It has a range of products, especially from the education sector. And from also from the learning part, you have the ICT learning part, but you also have a new science learning part and an early years learning part too. So let's dive into Arduino Uno. Now, what you saw on the previous one, the green one, was the Arduino Uno R3. What's changed with Uno R4, which you see on the screen, is that it is based on ESP32, right? So it has a 10-inch chip, but it also has an ESP32. And the power of these two, along with an OLED digital screen with the LED lights, makes it really powerful. But also what it makes it powerful is the new quick connector. And what you have is something called as 𝐀𝐫𝐝𝐻𝐸. So what you see on the right hand side is the Arduino plug and play kit, where you have these plug and play sensor. Now these, unlike the regular Arduino where you have to now take breadboards and now do wiring, you can plug and play this and they can be daisy chained together. Now, right now there are around three, five, seven of these which come in the kit, but most of the Spark Fun quick connectors work with this Arduino, and with this Arduino R4 Wi-Fi option, it kind of opens up a lot of options for educators, right? From not just doing C coding, but also then doing Python coding because it's based on ESP32. So these are a couple of changes. Again, under the hood, there are a lot of other changes. So you could also go ahead and buy the Arduino R4 without Wi-Fi, but just a small difference of price. And here, what you see is you see a little more detail in the quick overview. So if you're unsure, go to the Arduino website and just do a comparison and see what makes more sense for you. The Arduino Uno R4 has a lot more to offer with the price point. Give me a minute. Okay. Now let's look at the make kit in a little more detail. So the make kit comes with a board, and then that could be daisy chained with different sensors and connectors. It's called make tunos, but that really helps you to get an idea to a prototype stage very quickly. And then there are these other robotic kits for Arduino, which is one is the robotic arm, and on your right hand side you see is the science pack. This one is the physics pack, and then Arduino also has a new robot which is called Arduino Alvic. Alvic is something which was released around 6 to 8 months ago, which is based on ESP32 Arduino Nano form factor, but it has a complete driving base. It has quick adapters, a servo motor expansion, and also Lego adapter option. What's interesting is that it can be programmed via MicroPython, but apart from the Arduino IDE, but Arduino also has released a beta version of drag and drop coding, which could be then programmed via Make Block IDE. So that's the IDE for drag and drop programming with Arduino. I know there are open source Arduino block based like Arduino Blockly and many others. So, but this is something which is specifically designed for Alvik. It has these 360 servo motors inbuilt, and then with the Lego expanders, you can then program this to do a lot of robotics in your classroom. Uh, One thing which is not really talked about in the Arduino ecosystem, especially in the hobbyist ecosystem, coming towards the education ecosystem, is the support which Arduino gives to education. So you have something which is called the Projects Hub, where you get different ideas of what projects you could use, especially for ICT and science. Uh, One example is that there's a whole kit which is for the greenhouse kit, which has with all the hardware, the building material, but also has a whole course work. So the kids could do a self-paced course, as well as the teachers could then integrate it into environmental science as well as ICT. You also have a science kit, which is really great to then do data logging, understanding how data and science work together. Uh, so that's again, and you can do it via an iPad. You can do it via the mobile phone app. But then collecting data and then analyzing data for magnetic force or acceleration, gyroscope. All of this is again really great with the Arduino Science Journal, where you could then measure different values and then work on it. What's also interesting is Microsoft has released something called as Hacking STEM, where you can then connect an Arduino board right into an Excel sheet and then do data logging right into there. So that's again a great place for educators to then explore Arduino inside education environment. What I've seen students is build no now with the automatic hand sanitizers, automatic hand robotic arms with Excel. So again, this is a very good place for you to explore. And Arduino has ready-made lesson plans designed for educators. Uh, and some classroom management tips. One thing which I've always seen is educators are not engineers, and a lot of times they take projects which are based over instructables or from the hobbyist ecosystem. Now, hobbyists are tinkering, are playing around with wires and breadboards, but what you would ideally would use in a classroom is you would use stations. So you divide them into stations. If you're teaching C++, then Arduino IDE is your go-to tool. If you're teaching Python, then Arduino Labs has a new environment which is called MicroPython. Have a dedicated laptop with a wire, and then if you are really looking to go towards a cloud environment and really looking at expanding the ecosystem, you can then program Arduino via the cloud. You can purchase a premium subscription for Arduino for schools, where then you can get access to like a classroom portal, and then you can share codes and have a look at different students' work as a teacher management tool. Yeah, I mentioned workstations are great. So if you can have workstations where you have, if you have, even if you're looking at the Arduino starter kit and you have, okay, today we're going to focus on blinking an LED light, but these are your steps. This is what you need. And there are three things which you need to focus on in education is, can the students troubleshoot themselves? So is the hardware connected? Okay. Is the pin layout correct? Second, is the software calling the pins and has the correct libraries? Third is, which makes common sense, but is the code actually transferred to the Arduino board and it's running the actual code? And sometimes just using these LED lights or the LED or a sound or a buzzer is a great way to look at these things. I would also highly recommend to look at Tinkercad. So Tinkercad has a simulator of Arduino where you can then program the Arduino by block-based, do a simulation. Once the program is correct and the simulator is working, then they can look at the circuit diagram and then build it in the physical world. Yeah. So just to summarize, there are, as teaching strategies, you start off with very basic fundamentals of hello world, blinking LED light, input and output of sensors and actuators. Then you can move to a intermediate level where you do robotics and automation. Arduino Alvic is a good example. Arduino Science Kit is a good example. And then you go to a little more advanced level where then you can use the IoT kit, Arduino no, IoT dashboards, and then look at machine learning and all of that. So yes, in general, there are four components in the Arduino education world. You have the hardware and the sensor component. Then there's a whole online learning content. And I think apart from one or two courses, all the other courses are free. So for basic educators, right from introduction to MicroPython 101, introduction to science sensors, all of them is available. And then you can then go to advanced kits like the CTC kit and the engineering kit, which are more advanced, and then you get a pin code which comes along with the kit, which you can then activate your course. And also, the Arduino is designed as open source. The community was always a great place for people to, you know, to ask questions, to bounce ideas of each other. And there's a whole project hub as well as the whole hobbyist community which you can leverage while using the Arduino boards. The curriculum alignment, again, this is something which a lot of teachers do not know, but you have a curriculum alignment. An example on the screen is of the UK national curriculum. We have the similar one for NGSS and other curriculums. Uh, uh, and the last one, where is you also have certifications available from Arduino for teachers as well as for students. And the Arduino Junior certification is a great way for students to validate their skills, understand, and even then use that when they go for pursue STEM fields, universities. So yeah, that's I would really recommend if students are learned about Arduino, they can then validate their skills with this certification. As a Robots Got Talent, we offer Arduino courses, and for the next 2 months, we have the course available open for anyone. So please do feel free. Our colleague Abdelaziz has done an amazing job on designing this Robots Got Talent course, where you look at how Arduino basic programming, then using Tinkercad, and then some syntax programs, and these are all step by step with the teacher guide as well as students workload. So that's all me. Thank you so much for joining. I hope this recorded video was helpful for you to get an overview of Arduino in education. I will be going into more details tomorrow, so join me tomorrow at 5 p.m. For Arduino in education details. Bye.
Education, Murtaza actually explained like almost everything, and that's awesome. Maybe I'll go with you through the free resources that we have in Robots Get Talents platforms, which is like Robots Get Talents, the website, and Robo app, the Android application, to see like how could we help you in your classroom with our Arduino curriculum. So first of all, let me give you a bit of an introduction about RGT. So RGT, Robots Got Talents, has been doing free robotics courses for 8 years now. So next month, we're celebrating our 8th anniversary. We are more like well known for our set-based curriculums. So we've built curriculums for a bunch of Lego platforms, Weedle, Mindstorm, Spike Prime, Spike Essential. And lately, in the past few years, we were willing to add more of the open source platforms. Similar to Arduino, we are also currently creating more advanced courses for Python, MicroPython. There's like a CAT course, which is under construction right now. And the reason why we're moving into this direction is that we really want to make sure that everyone could find like free, high quality resources for their classroom. So currently there are like over 2,000 schools using our curriculums in 94 countries. And we've like reached nearly over 500,000 visitors in the last 4 years. Uh, so yeah, we have like pretty good numbers. I'll share like a few of our statistics with you right now. Let me share the website. So most people here are from like UAE and India and somewhere else. Is that right? Is there like anyone from other time zones? Because it's in New Zealand, it's right now like 2 a.m. for me here. So yeah, but I love doing this. That's awesome. Uh, By the way, can I ask you how is the workshop going till now? As I told you, like today we're just going through the boring stuff. So if you're enjoying it, just do this emoji. If not really, do the clapping emoji. If oh, that's really bad, do the crying emoji. Oh, thank you. Thank you. Okay. That's good. We are doing our best to make it better, and I promise that tomorrow would be like much, much better with all the interesting stuff that we're going to explain. So let me give you a tour of the Robots Get Talents website. So here is the main page. Also, other than classroom courses, we have something called the zones or the like learning lessons. So here we have a bunch of topics and exercises for Arduino, BBC microbits, Spike Essential, Mindstorms EV3, VRT, and other platforms. We also sponsor some online and offline robotics competitions like RoboJam. So let's first check the lessons. We go to lessons, Arduino, and then you have all of these lessons. Uh, just choose the topic that you need, and yeah, just this. It's free. It's available in like presentation format and a PDF. You want to check this topic, you want to use it in classroom, just press learn more. Yeah, there is a bit of an introduction about this. View PDF. And you could just like view the lesson content with a few exercises. And as I told you, that's like always available, 100% free and available for everyone. It's also mobile compatible, so you could also view this from your mobile device. Yeah. So there is another thing that I want to show you. It's our Arduino course. This curriculum was built by Abdelaziz Hamdoun. He did an amazing work actually developing this curriculum. I think it took us about like 2 to 3 years to finish the development of the curriculum. And celebrating uh, Arduino's 20th anniversary, and just a way to thank you guys for participating in this workshop, we've decided to have this course available with no registration required for March and April. So this is the course information thing. In regular cases, you need to fill this course hosting request, and within 48 hours, you'd receive your course passcodes. But for now, it's really easy. You don't need to do any of this. You just go to login, choose Arduino Discovery, and there is no password required. Do this. Yeah, here's the course. So that's the message for this event. Here's the course available for free, and that's the resources for student. That's called the student zone. Abdelaziz will go further with you through this. I also want to share with you the content that we have in the teacher zone to see how this would be useful for your classroom. Here's the teacher zone. So you have a few things you could download. That's including the lesson plan. Here is what's covered in lesson 1. That's the exercises. D is for discovery exercise, B for practice exercise. This course consists of 8 lessons. So yeah, lesson 1, lesson 2, lesson 3, lesson 4, lesson 5, lesson 6, lesson 7, lesson 8. So here's the lesson plan. You can of course download this and keep it in your classroom if you want. Oh, you weren't able to see this. Oh, sorry. Here's lesson 1, lesson 2, lesson 3, lesson 4, lesson 5, lesson 6, lesson 7, lesson 8. And what else can we view? back to here. There's also a bunch of advertising material that we provide. That's like just like pre-made illustrations that you could download and use it for like your own marketing purpose. That's also really useful. We also provide you with certificate templates, student zone handouts, exercises codes. So all of the exercises that are in the Arduino Discovery course, student zone, you could just like download all the C++ Arduino codes from here after you're done. We also have some classroom quizzes that you could use for your classroom. You could also access this course through Robo app, which is our Android free app. It's available on Google Play. So yeah, back to the student zone. Here is the topic selector. Choose the topic that you need to teach in this lesson if you don't want to follow our lesson plan. Here's the IR exercise. Like, it's an amazing course. I'm sure you'd love it, and I hope it's helpful for you and for your students. Again, that's most of our way to thank you for attending this and to thank Arduino for allowing us to organize this amazing event and to be part of Arduino Days 2025. So again, this course would be available through March and April. And after that, for everyone who filled the form for this event, you will receive the login passcodes, unlimited access for the updated version of this course. So you could access this course forever with any number of students. It's free, but like we have some restrictions, like in regular cases, so you can't host more than 2-3 courses in a year, but now you could just use it forever. That's a way for us to thank you for being here with us. So let's go back to our main presentation. So now we're diving through our third session. This one, we'll just like go through the fundamentals of Arduino, and Abdelaziz will guide you through some basic Arduino projects. This would be an amazing session. Abdelaziz is the developer of the Arduino course, and he's also the head of the course development team at Robots Got Talents. He's been working with us for 4 years now. Also, something that I maybe forgot to mention for those who don't know, Robots Got Talents is a volunteer-based platform. So everyone like collaborating in the RGT project is like a volunteer is doing this just for the purpose of the mission and for helping people and for spreading education and robotics knowledge. So Abdelaziz, do you want to join now?
Yeah. Hello,
Yeah.
everyone.
Thank you.
Very nice to meet you all. Yeah, my name is Abdelaziz. I'm really grateful to be joining you today. We are going to celebrate the Arduino birthday. Hopefully, you enjoy this presentation and workshop. So I will share my screen now and. As I was saying, our course consists of 8 lessons. Here we have like a quick access menu, selecting the topics or the lessons you want to jump in right through. So let's jump right through to lesson 1. So, in lesson 1, we will take a brief introduction to microcontrollers, Arduino boards, the syntax and variables, and a little bit of hardware, talking about LEDs and resistors and buzzers and stuff like that. So the microcontroller is basically the computer or the main processing unit of the Arduino. It has input pins and output pins. Output pins are used to drive external devices, whether it's an LED, LCD, or a motor. Input pins are used to read input from a sensor or a push button or any other devices that send data to the Arduino. So there are multiple of Arduino boards. We have the familiar Arduino Uno, we have Arduino Mega, Arduino Nano, Arduino, the new Arduino Giga, and Arduino R4. Murtaza talked about earlier. They have much better microcontroller chips and Wi-Fi capabilities and also Bluetooth capabilities. We all know the Arduino Uno. It's the most famous Arduino out there. It's like there are also a lot of it's like very accessible in almost every place you can find an Arduino Uno. So it's the main board we are using in this course. We selected the Arduino Uno. Okay, the Arduino Uno has this is like the pinouts of the board. I think most of you are familiar with it. If they're new people who haven't used Arduino before, there are 6 analog pins from A0 to A5. Those are the analog pins on the bottom left here. They are used to get analog signal, so it's not digital. It's not 0 or 5 volts. It might be in between, or it might be a sine wave. So it's not a continuous 5 volts. We have the power pins, the 3 volts and 5 volts. We have 2 ground pins. The VN power, it's if you want to power your Arduino externally, not from your laptop or PC, you can power it through the power input. On the right here, we have the digital pins. Those are 13 digital pins from 0 to 13. Sorry, 14 digital pins. We also have an extra ground pin here. The PWM pins, those are with the squiggly line. Those are used for pulse width modulation. They control speed. It's like the most common application for it to control speed. Also, you can control it to blink an LED or something like that. Or servos. Yeah, controlling servos and motors in general. So this is the Arduino IDE. I think most of you are familiar with it. We can go like quickly through it. Here we have the main GUI here. Void setup. You put your code here that it will execute once. Then the void loop here, if you want the code to loop forever or for a certain amount of time, you put the code here. Here we have like those icons you can verify your code, upload or save your code. We will go through this when we will write a code together. So I will explain it more and when we get to that point. Here you have to you can save your file. You can add examples. Arduino has some built-in examples. You can create a new sketch or open a new sketch. Open an old sketch. Sorry. We will go through all these steps when we get to the coding. Okay. So the void loop and void setup, those are where your code will be written inside of those. So as I said earlier, the void loop, it goes forever. It goes line by line and it repeats itself. The void setup, it executes only once. So in the void setup, this is where you wanna initialize your variables, or say tell the Arduino which pin is an input and which pin is an output, and so on. In the void loop, here you can control the pins you assigned an output or input them to them. You can control it to, for example, you can tell the pin to be high, for example, to output 5 volts, or you can tell the pin to read an input, and so on. Yeah, this is what I said from a minute. Moving to the next slide. So it's the Arduino IDE language. It's very similar to C++. So the semicolon, almost every line must end with semicolon. There are some exceptions. The curly brackets, that's where you start and end your void setup and void loop with. In parentheses, there are some, we use it in functions. Some functions use it, so it's very important to know your syntax. Single line comments or multi-line comments, those are ways to comment your line. We will talk about them when we get to the code. So variables, it's a variable is like a storage unit where you can initialize a variable. It can store data and store the data in the memory space of the microcontroller. There are a lot of variables types. We have integers, we have floats. It's like decimals. We have doubles and strings. Also, the course will talk about these variables in much details in the later lessons. Here are one of the most function in the Arduino, the programming language. It's the pin mode. This is where you tell the Arduino what to do with the pin. For example, let's say digital pin 8. Do you want it to be an input or an output? Here where you tell the Arduino what to do with this pin. The other function is digital write. Digital write is used to tell the Arduino to output 0 volts or 5 volts. 0 volt, you will type the value here will be low. This is mean you're telling the Arduino to output 0 volts. If you typed high, this is mean you tell the Arduino to put the 5 volts output. So we can talk about some hardware. LEDs. LEDs are called light. They stand for light emitting diodes, made of semiconductor material. The most important thing in the LEDs are the legs. There is an anode and a cathode. So LED has a polarity. You need to connect the 5 volts or your signal to the plus, to the anode, and the ground to the cathode. Resistors, we use them to protect our components, to limit the current from maybe if you connect an LED can't handle the 5 volts. It's need a lower voltage, so we connect a resistor, so we have a voltage drop and the LED doesn't burn. This example can apply to other components. So we use resistors to protect our components. Okay, discovery exercise. Here in the course, we have 2 types of exercise. We have a discovery exercise and a practice exercise. So a discovery exercise, we tell you the task, then we show you the code and we don't explain it. You can to discover it by yourself. On the other hand, the practice exercise, we will explain the code one by one and walk you through it. So it's kind of to exercise the student to use his thinking and maybe tinker with the code. Like, for example, he can say, "What if I change this value from 8 to 10, or I change the low to high? What will happen?" This is the purpose of having two different kind of exercises. This exercise very fast. We can try to build it together. Uh, we have most of our circuitry is we did it on Tinkercad. I'm sure you're familiar with Tinkercad. Um, it's a like a online simulator where you can add an Arduino components and connect your circuit. Uh, then you can try the code, upload the code if you don't have actually an Arduino. If you don't have the physical hardware, you can always try Tinkercad. So yeah, let's try to use Tinkercad. So here we have an Arduino. Usually you will start with a blank space like this. Here we have the components, list of components. There are a lot of components, just like a basic component. You can select all. You can, if you want a specific component, you can always search for it. But we will get an Arduino R3. We need a small breadboard also. And we need an LED and a resistor. Okay, as we speak earlier, the LED had an anode and a cathode. The anode is the plus side and the cathode is the negative. So we can connect it here. We can connect the ground pin. You can always, if you love your circuitry to be neat, you can control the angles of your wires. Also, here on the top, you can connect. You can control the colors of the wires and the type of them. If you want a hookup or alligator wires. So we're gonna use digital pin 13 for this exercise. We can put it here. So don't forget to put your resistor. It's very important. You can control the value. You know, the code tab. You can choose a. So as we talked earlier, we have the void setup, the void. After we made our variable the LED pin, then we go to the void setup. the void setup, we have a pin. It's pin 13. What do we want to do with it? It's gonna be an output. We want to control the LED with it, so it's gonna be an output. So we tell the Arduino the LED, the pin we are working on, then the output. We named it. We made a variable up there. It's an int LED pin. If we didn't do that, we can just erase this line, and instead of LED pin, we can just say pin 13. Okay. Then here we come. This is the void setup. We just initialize. We told the Arduino we want this to be an output. Then we tell the Arduino to light up the LED to send 5 volts. So we tell him LED. We should tell him here pin 13 because we're using pins, not using variables. I'm gonna show you why we need to use variables. I think you already know. So this code, the digital write high, it's gonna send 5 volts to the LED. Then it will wait. This is a delay function. It will wait 1000 millisecond, which equals to 1 second. Then digital write pin 13 low. It will send 0 volts and then a delay for 1 second. Then the loop will repeat itself. It's because it's a void loop. It will go to infinity. The void setup will just execute once. You tell the Arduino it's an output, then the Arduino doesn't read it again. It's just gonna loop here. So we can start the code. This should make the LED blink. So it's blinking. So this is an error here. It tells like there is a short circuit, or like something is wrong, or like the current is too much for the Arduino to handle. Why we use resistance?
Yeah.
We use resistance to protect our components.
You know,
Uh,
Abdelaziz, at first when when I had my first Arduino, yeah, I
yeah.
blew it up like in a week. I used like a bunch of DC motors without a motor driver, and it just like exploded. It was really sad. I used to like not like Arduino at that time. Like it was my least favorite thing after organizing webinars, but now organizing webinars is my least favorite thing. So, yeah, awesome. Great job.
Thanks.
Continue.
So
Yeah.
this is just the basic code. So the variables. Speaking of variables, let's say for example we have this line here. For some example, we need it to repeat itself. For example, 100 times. So we need control. We're gonna just paste this. So now we have, let's say you want to change this pin. You want to put, it's a red LED, for example. You want to put a green LED and you want another red LED in another place. So now you need to physically remove this wire and connect it to another pin, for example. Now the code won't work because you're telling the Arduino to send 5 volts to 13, and now you're connecting the LED to pin 12. It's not gonna work. So you're gonna come here and change all of this to 12. But if we had a variable like earlier, just gonna control Z my way. Yeah, like this, and this was copied 100 times, for example. Now we just can change the variable, what's connected, the variable here. But instead of saying LED pin is connected to pin 13, it's now connected to pin 12, and you don't have to do anything here. So this is why we use the variables. So this is the same here. It's the same what we did. We explain the code overview. We tell it what's the blink. We explain the void loop more into more details. We explain every function. We used pin mode, void loop. When we get to future lessons, there will be more advanced functions, and we also explain every function in the code. So yeah, here we go into detail on the delay function. So breadboards, breadboards are very important for prototyping. I think most of you know how it works, but basically the columns are connected. Every column is connected, so there is a physical connection. It's connected to one conductor. It's all conducting all these points. It's a one piece of material or a one wire with holes in it. Yes. Also, it's important to know that this gap in the middle, it's not connected. So, like the top the top columns, sorry, are connected together, and the bottom columns are separately connected together. They're not connected to each other. Here we have a power rail. You can, if you need a power supply, 5 volts and a ground. If you have like multiple components, not just one LED, your projects 100% will get bigger, and you will need more components. So you're gonna need a power rail eventually to power all these sensors and LEDs and stuff. Here, this is another discovery exercise. We control multiple LEDs. It's just the same as one LED. Instead of one variable, you're gonna have five variables. Instead of one digital mode, one pin mode function, it's gonna be 5 pin mode functions. You're gonna define, for example, this is connected to pin 13. You're gonna say pin 13 output, pin 12 output, pin 11 output, and so on until you finish all your LEDs. Also, resistance is very important, as we've seen. So this here we explain the code again. It's the pin mode that we initiated the variables or declared the variables. Then the void setup, the pin mode function, we're telling the Arduino all these pins are an output. Then we have the digital write high low to make it blink. So next component we have is buzzers. Buzzers, it's a fun way to add sound to your projects. It's a very unique device. It can be very noisy. You can use it to, for example, to build an alarm, or to, I don't know, maybe make a prank on your friends to annoy them or something like that. There are 2 types of buzzers. There are an active buzzer. It has only one tone. You can't manipulate the frequency of the sound it emits. Passive buzzer you can control it with PWM to make it produce sound or music. It's not gonna be as good as a speaker, but it can work you can produce songs with it, as we will see in another example today. So we can try to connect this very fast. It's a simple circuit. Instead of this LED, we can delete it and add a buzzer. You can search for it. Buzzer. It's called the buzzer or a bezel. So the resistance should be going to the positive. Again, I connected to pin 13. So the buzzer is an output. The Arduino doesn't know if you're connecting it to a buzzer or it's connected to an LED. It doesn't matter to it. So we're gonna just use the same code. I think I'm reversing the polarity here. Need to. Right. Okay. So the code is just gonna delete all of this. Instead of LED pin, we can name it bus pin, but the Arduino doesn't know it's a buzzer. It's just an output device. It will send it 5 volt. It doesn't care if it's an LED, it's a motor, it's a buzzer. Uh, you can you type this bus pin. Just you as the programmer of another one, another person is viewing your code to because he can be able to understand the code or some of it. Mm. Yeah, so we forgot a semicolon here. As you can see, it's producing some sounds. It's very unpleasant. Hmm. So also the delay time. The delay time can control the kind of the frequency or the tone of the buzzer. So if we reduce the delay time, it should sound differently. No, it's louder than now. It's almost continuous speaking. Yeah, it's very noisy. Um, Also, we have quizzes in our courses. Every now and then, we have a quiz to test the student or the learner on how much did he understand of the course. Uh, so then the lesson 2, we're building on what we learned in the past lesson, and we are adding more components like push buttons, and we are combining components with each other, like LEDs and buzzers and buttons. Here, a practice exercise. We're making a traffic light with a buzzer. It's like the familiar traffic light colors, the red, yellow, and green, and a buzzer. The buzzer should make a sound when it's only red. So this is a circuitry in details. Then we put the code. So the code, we put a delay time. The delay time is for the LEDs to blink. Here the question is to wait 5 seconds, then change the color of the LEDs, or change the traffic light. We initialize some variables for the red LED, the yellow LED, the green LED, and the bus pin. We tell the Arduino what pins are outputs. Then we put the digital right. We tell it we start with the red on. Then if the red is on, the buzzer must be on. So it should be high, high. Then we wait the delay time, which is 5 seconds. Then we close the buzz pin and the LED pin. We send them 0 volts, so they shut down. We send the 5 volt to the yellow LED. It will stay on for 200 seconds. Then the yellow LED will turn off. Then the green LED will turn on with the delay time of 5 seconds. Here we explain the analog with digital signals, how they differ. As I said earlier, the analog signal, it's a continuous sine wave. It's the value of the voltage change from 0 to 5 volts. Digital signals are discrete signals or continuous signals. They can either be on or off. Is it a 1 volt or 0 volt? Here we come again and explain more hardware. What is a potentiometer or a variable resistance? The push buttons and how to use it. Here we explain the digital read function. How you can. Here we in the past lessons we only dealt with outputs, the LEDs and buzzers. Now we introduce them to other components like the button. You can read from the button if it's, for example, if the button is pressed or unpressed, you need to read that to do a specific thing. For example, to turn an LED on or to turn a motor or whatever your application is. Here we have a discovery exercise. Here, when you press the button, it's gonna need to the buzzer should make a sound. Here is a schematic of the circuit. Here is the code. We explain another function, delay microseconds. It's the normal delay function. It works in a millisecond. So a millisecond is 10 to the power of -3 of a second. So if you want to wait 1 second, you're gonna, with the normal delay function, you're gonna type 1000. Sorry. Microseconds, it's 10 to the power of -6. So it's 1 millionth of a second. Some fast sensors need this function. We also explain this in further and more advanced lessons, lesson 7 and 8. Here we introduce the student to the basics of logic, an if statement. If this happens, do this, and if this didn't happen, do that. We continue to build on this. If, then if else, then we will introduce and operator and or operator. Less than, bigger than, less than or equal, to build more advanced projects. Also, we have some the piece of code, I think it's called. So it's much easier for the student to understand the logic. Here we have a video. Um, Sorry, I need to check something. Just give me 1 minute. I'm sorry.
No worries, Abdelaziz. Take your time.
Yeah, so from now on, the projects will only get more interesting and more fun as you go on, or as the student goes on. Uh, in the advanced lesson, we will introduce DC motors, servo motors. Then we will introduce sensors. We will, of course, talk about libraries and how, if you want to include a library or make a library. Uh, yeah, so I think this course is a good starting point if you are a beginner, or if you want to teach young people about Arduino and, and tinkering. So yeah, this is basically this was an overview of the first two lessons we have in this course. Uh, we're gonna do like a demonstration after the next session, where we gonna sing a happy birthday song to Arduino using buzzers and LEDs. So I hope you stick until that time, and it's gonna be fun.
Wow, that's
Yeah.
amazing, and it's a great idea. Thank you, Abdelaziz, for delivering this great presentation and for creating this amazing course.
Yeah, you're
Uh,
welcome.
Thank you.
Sorry.
Yeah, no worries.
Mm.
Uh, yeah, let me share my screen back.
Yep.
Yeah.
Thank you.
So again, this course is available with no login required through this month and next month as well. Where's the presentation? Yeah, here's the course. It's called Arduino Discovery Core Course. So now with the question, answers, and discussions. So let's just talk. I want to hear from you. How are you feeling about this workshop? Were you expecting? What would you like us to include tomorrow? If you have any questions for Sandipan, Abdelaziz, or myself, just feel free to ask. I want to just like chat with you.
Is the screen share visible now?
No. Are you sharing
Oh,
like the entire window
yeah, I'm sharing the entire screen.
screen? Okay. Oh yeah, it's working now.
Okay, cool. Um, so here I'm gonna just like make those LEDs blink and sync with the song, or it will the buzzer will sing "Happy Birthday" to you. So the components we need just a buzzer, three LEDs that can be any color, um, and then we have the Arduino. We also need to get some resistors. We need three resistors. So we're gonna connect them to the anode of each LED. We're gonna choose any random pins. Doesn't really matter that much. We're gonna go pin 5, 6, and 7. Or I have another idea. We can just connect all the LEDs to just one pin.
That's because we don't need any of them to operate independently, right?
Differently. Yeah.
Yeah. So
We just need them to all to blink from one source. We don't need
yeah,
to blink independently.
great. So then one pin would be used, right?
One,
A single
yeah,
pin for
exactly.
the LEDs.
Just
Okay.
one pin.
Yes.
I'm just gonna need to bridge over this gap because those
Yeah.
columns are not connected to these columns. Gonna connect
Yes.
our ground
Or
and
maybe you
okay.
could just use it on plus and minus. That could be helpful for you too.
Yeah, we can do that. It's, as Sandipan said, we can use
Yeah.
minus. So we have here we have multiple components. We have the buzzer, and we have several LEDs. So we can make a common ground. We connect this, and we take a signal cable. Let's say pin 8, for example. So for the code, I wrote this code. I'm gonna explain it to you. So if any of you is a musician or play any musical instrument or something like that, or a music teacher, you know that there is like notes, the C sharp, D, and so on. So every note has a frequency. So we need to define each note. For example, note C4, it has a frequency of 262 hertz. The note G4, for example, has a frequency of 392 hertz. So we're gonna assemble the notes of the Happy Birthday, thank you, Happy Birthday song. Sorry, we're gonna assemble them in an array. We explain also this in our Arduino course. An array is it's for example, it's like a big storage unit where you can store variables or data in it. So we put the nodes on an array. Then we have something called a node duration, like It's also it's in the music world, or if you're a musician or play music, like there's a quarter note or a half note, and so on. So, like for example, the first note C4 will play for a duration of a quarter note, and so on. All of this before the void setup. In the void setup, we're just gonna tell the Arduino we have LED connected to pin 13. They are an output. Okay. Then we will make a for loop. We explain loops in our course also. So this for loop will it will go through every element in the array, every note. So it can play. So the buzzer can play every note. It will play C4, for example, first, then C4 again, D4, C4, F4, and so on. So the for loop will go through the array. It will start from 0 and will increase until it's plus 24, because we have 24 elements in the array. So we have this tone. This is a function. It's called a tone function. The tone function needs a pin, like your sound device, your buzzer, or your speaker. What pin it connected to? We connected it to pin 8. If we connected it to pin 7 or 6, for example, I'm gonna type 6 or 7 here. It's need the array of notes. This what note will it play? What set of frequencies it will play? And it also need an input from you for the note duration. As for the LEDs, we're gonna at every note, at every increment of the for loop, it will blink. It will turn on high for the duration divided by 2. You can, if you wanted to blink faster, you can divide it by a factor bigger than 2, for example, a 1 or a 4. Then we have a pause. Then we pause. So no tone as kill the buzzer, so it doesn't go forever. You notice there is something odd here. All this code is written in the void setter. It's not in the void loop, because we don't need it to repeat itself. We're just gonna sing happy birthday once. We don't need it to loop forever. So we forgot something here. We forgot our resistor. Need to add a resistor here. And leave it at 1K ohm. And let's hope it works.